Now this is just a section to quickly run through the practical, so that you know what to expect. So,
sorts of cables, coaxial cables unbalanced. Right, self-explanatory. And we've talked about that before.
Yep.
And we talked about that before.
Yeah, these are reiterations with a few additional slides.
Okay.
So,
and antennas.
half-wave folded quarter wave.
Ground plane.
Ground plane.
Yep.
Yagis.
I like that name, Yagi.
Yeah.
They never put Uda in there though. And there were two guys. There were two scientists, Yagi and Uda.
Dr.
They never put
Yagi.
Uda in there.
Dr. Yagi was the man that's known by. Yeah. Infed. And then traps. Connecting things together. Antenna tuning unit, the last in the line, which I guess is significant. And symbols.
So
and the ECD is the significant that. Yeah, a few things there that I haven't mentioned before, aren't they? If you're sort of looking for a contact, you're sort of trying to establish a contact with somebody on HF, we use this symbol, this abbreviation CQ. CQ, I'm seeking you. So CQ, CQ, this is VK7KK. Now in VHF you tend not to do that, you tend to just say VK7KK listening sort of thing rather than using CQ. But using CQ is always right. Phonetic alphabet, in days of old when we used Morse code, you had this series of Q codes which are an abbreviated way of talking about things. Instead of asking somebody where do you live, you'd say your QTH. If you wanted to tell somebody that you had a bit of interference, you'd say there's QRM on your signal and so on. So you'll find in that handbook that there's a list of these Q codes. There are a few of them that we sort of use a bit. One of the things that we're going to ask you to do is to QSY, which means change in frequency. Others you might use a QRT, I'm sort of going cheerio sort of thing. So, well, even to a thing called a QSO is a contact with somebody. So there's some of these Q codes you'll get to use and you'll hear and you'll make it part of your vocabulary. The signal strength reporting is also a standard sort of system. There's 2 or 3 components to a report that you give somebody. The first one is something called readability, and this is rated in 0, I suppose, to 5. So if you think somebody is perfectly understandable, you'd give them a readability of 5. If you have a little bit of difficulty, it might be readability of 4 or something like that. But, you know, people tend to take a bit of an insult if you don't give them a readability of 5. Anyway, the next component is signal strength, and this goes up to 9, but that's not good enough. So we also have so many dB over 9. So you have you'll find on most of the equipment it's got a little scale that says 40 dB over 9, 80 dB over 9, and so on. So for AM or radio telephony signal report, you'll give them those 2 numbers, readable 5, strength 9. So your signal is readable 5, strength 9, or 5 and 9, or 5 and 9 plus 20 dB. They add an extra one when you're dealing with Morse code, and that's how the the Morse sounds. That goes up to 9. We won't worry about that. Mentioned changing frequency, QSYing. If you find you're sort of being interfered with somebody, you might want to change to a different frequency. So you'd say to the person, look, let's QSY 10 kilohertz higher, and back and get confirmation from them. And then you'd go and say, all right, changing frequency to 3675, whatever it is. And you'll change frequency and call them on that other new frequency. So we'll get you to do that. CTCS and DTMF tones for an IRP contact. Come on, you talk about that.
Well, it's the next slide.
Next slide. Good. Demonstrate the use of breaks between overs and purpose. This is it's important anywhere you're having a contact. You don't own the frequency, you don't own the airwave, so you need to leave a little bit of a break so if somebody else wants to come on and say hello, they can do so. It's often more important on repeaters because they often have timeout facilities, so if somebody's sort of talking for 5 minutes, they might switch themselves off. So that if you have a break and give the repeater time to drop out, it sort of breaks the continuity as well as giving somebody else a chance to come in.
Sorry, is that to stop like a rogue transmitter from just holding the repeater for a period of time?
Yeah, that's right. So we had one a couple of weeks ago, didn't we? Somebody had their...
Yeah, day and a half.
Day and a half, was it?
Oh,
yeah.
Jeez.
I don't know why obviously didn't have a timeout.
No, there's usually what they call a watchdog timer on it, which is what you're talking about.
Yeah.
So it resets after a certain period of time.
So I'm guessing if for some reason someone's mic's gone open circuit, then it's just going to keep the transmitter.
Like this case, somebody had their transmitter jammed on. Yeah.
I had my scanner scanning the frequency and it was just a faint noise.
Yeah.
So I would say that might have been...
They're shack.
Yeah.
We were all listening to try and work out who it was, but they wouldn't say anything. They wouldn't say anything for the whole time.
Because now it's all white noise now, so...
Yeah. Which is that, and you can get rid of that with your squelch.
Okay.
So
Yeah.
There's no signal there. Now this is, you need to know the concept of these two. Continuous tone coded squelch systems, or CDCSS. What it basically is there is a subaudible tone in the range of 67 to 257 hertz, so right down low. You can only just hear those frequencies, and probably not hear those frequencies. That's why they're down so low. And what they do is they superimpose those frequencies on your voice. So when you push to talk on your radio, it's transmitting one of those frequencies, and the receiver at the other end is listening for that frequency. So it knows that that's a real signal. It's not just noise at a particular frequency. So it doesn't just keep opening up the repeater or whatever. It actually, it's listening and goes, I've got a 67 hertz tone, that's a real frequency, I'll open up the squelch. So that's the system that we use. We're going to be using that when we do the practical, because the transmitter we're going to be using, the repeater we're going to be using, has actually got a 141 hertz tone on it. The other one that we use, which is probably more familiar to people, when you type in a number on your phone, on your mobile phone or landline or whatever, you hear those tones as you type it in. That's dual tone multiple frequency, DTMF. So what they do is, some very smart people back a long time ago came up with the fact that if you mix two frequencies together, you get another unique frequency that is very hard to interfere with and very easy to receive. So what that does is enable you to, in this case, control things. And what we're going to be using this for is the Internet Repeater Linking Project, which is the next slide, I think. Yeah, okay. As part of the practical, we're going to be using the IRLP node, and we're actually going to be using DTMF by typing in a number on the keypad using DTMF to get to another repeater in New Zealand.
Oh.
So we're actually going to be using DTMF to do that, and we're going to be using the Internet Repeater Linking Project. All that is 2 repeaters, one in here and one in New Zealand in that particular case. They're both connected via the internet. So what you can do is dial them up using a 4-digit number, and you can connect those 2 repeaters together. And when you talk on this repeater, you're coming out on the other repeater as well. So that's just a thing that we're going to be doing. And repeaters in general, the key thing about repeaters is it's a transmitter and receiver on a hilltop listening on a particular frequency. It receives and transmits on different frequencies, so that's how they work. And it's to extend range with VHF and UHF. VHF and UHF, line of sight mode. Stick a repeater on a big hill somewhere, and you're going to be getting further, much further. So that's, and we'll show you a repeater, although it's not terribly exciting. I'll just do some expectation management. But there's a repeater out the back, and we'll show you what one looks like. So yeah, I think that might be.
That's the last one, is it?
Just curious with the repeaters.
Yep.
On the CB band channel 2, there's a funny CW tone. Will that be you guys?
No. That's okay. That's a legal requirement. You have to identify. Even a repeater has to identify themselves.
Yep.
And so every 10 minutes, what you find is a CW ident,
Okay.
and that'll be the call sign of that particular repeater.
Okay.
Some have CW, so some have Morse code, and some have voice. Some will actually say the repeater.
There's one, I think, Matt Nelson's.
Yeah, Matt Nelson channel 8 for voice.
Yeah,
Yep.
it's got voice.
Yeah.
And there's number 2. I'm not sure where that one's located, but that's got CW.
Yeah. Okay.
Because that comes through my CB radio every so often.
Yeah, and that's the repeater identifying themselves.
Okay.
They're a transmitter. They have the same requirement.
Yep.
So yeah, so this is one of the things we're going to be doing is just taking note of the power output of the transmitter when we do the practical, and we're also going to be taking note of the SWR when we do the practical. So this is just it shows you that it's under 1.5, fantastic, and what the power meter up the top is telling you that you're putting out just under 5 watts. So yeah.
Oh, that's your power meter up there.
Up the top, yeah. Signal S slash PO is signal and power. So when you're receiving,
it's an S meter.
Yeah, it's a signal meter. And Reg was talking about a signal strength of readability of 5, signal strength of 9. That scale there, 1, 5, 9, is the 0 to 9 scale, the strength scale.
This must be what, 20 dB?
Yep.
40 dB,
40,
60 dB over
Yep.
strength 9.
So when we're doing the practical and we're doing the contact, I'll actually get you to look at that, and then we'll make that the signal report that you actually then tell the other station.
Okay.
Now I'll just tell you up front, we're going to be transmitting between this room and that room. so if it's nothing less than 5.9, I'll be a bit concerned. But anyway,
What's the ID rather?
ID. It's current. The transmitter's drawing.
Okay, cool.
Yeah.
I've got
So-
a symbol of eyes.
Yeah,
It's current.
that's 1 amp basically.
Oh, it's down the bottom.
Yeah.
Yeah.
So it's drawing 1 amp when it's transmitting at that particular point in time. Oh, reminder about safety. Because I'm going to ask you a question. We're going to ask you a question about safety, and it might be any of those.
Sorry, just going to if you go, hold this wire for a second.
Well, I switch this switch on. And that's it.